Good morning, children. In the last class we learned how to solve the problems. Okay, we solved the few problems related to the Atwood machine, and today we'll be going with another topic, that is the Newton's third law. Before that, already we learned the Newton's first law. Newton's first law says that any object which is in the state of rest or state of motion continues to be in the same state until some external force acts on it. Newton's first law is also called as the law of inertia, whereas inertia is the tendency of a body which is in the state of rest or state of motion continues to be in the same state of rest or motion, or which resists the change in the state of rest or motion is called as the inertia. Okay, inertia is of three types, that is the inertia of rest, inertia of motion, and inertia of direction. And next we learn the Newton's second law. Newton's second law explains about the definition of a force. Okay, next the third one what we are having is Newton's third law. Newton's third law. Newton's third law. Newton's third law. What is Newton's third law? Newton's third law says that for every action there is equal and opposite reaction. For every action there is equal and opposite reaction. Action is equals to minus reaction. Action is equal to the reaction, but it is in the negative direction. Action is equals to negative reaction. For every action there is equal and opposite reaction. For this, in the textbook he had given an activity, that is activity 6, related to pulling of the two springs. Pulling of the two springs. When we pull the springs with the same force on the either side, okay, we can obtain that the same force is exerted on the two springs. The same force is exerted on the two springs. Okay, here is saying that let us take two springs of equal calibrations. Equal calibrations means equal values. Okay, and connect the two springs balances as shown in the figure. Pull the springs in the opposite direction as shown in the figure. What do you notice from the readings in the two springs? The two springs gives the same reading, children. The two springs gives the same reading. Are the readings of the two springs balanced the same? Yes, they will be balancing of the same. Okay, are we able to make the spring balance to show different readings by pulling them simultaneously in the opposite direction? Okay, why? He is asking. Are we able to make the spring balances to show different readings? No, we cannot make the springs in the different readings them simultaneously in opposite direction. No, we cannot. Okay, according to the third law, when an object exerts a force on the other object, the second object is also exerting of the same force. According to the second law, when a force is acting upon any object, that object which is acting of the force also will be opposing the force in the opposite direction. That means whenever, according to the Newton's third law, when if I press the board, okay, the board also presses me. The board also, it presses me. If I press the wall, okay, if I push the wall, the wall also pushes me. That is according to the Newton's third law. Okay, and here two opposing forces are called as the action and reaction pair. These two opposite forces, they are called as one is action, the other one is the reaction force. Okay, children. Newton's third law explains when an object exerts a force on the other object. That means Newton's third law always explains that a force exerting on the another object. Okay, it explains what happens when one object exerts a force on the other object. Okay, if you are walking on the ground at each step, that you know that your feet exert some force on the ground. Are you thinking that the ground also exerts same force in the opposite direction? Yes, when we push our toe to the ground, the ground also pushes us. Okay, children, it is not surprising to hear that when you push a wall, the wall also pushes you back. The action and the minus reaction. Okay, the force of AB, here it is given as force of AB is equals to force of BA. Force of AB is equal to the force of the BA. Okay children, therefore if the net force acting on AB is equal to the net force acting on the BA. Okay, this is about the action is equals to minus reaction children. Action acting on the two opposite forces, but here these acting, but they will be acting in the negative direction, opposite sign. The negative indicates the opposite sign children. Okay, and here Newton's here the action reaction pairs in Newton's third law also represent forces acting on two different bodies simultaneously. When birds fly, whenever when the birds fly, they push the air backward. Normally, whenever when we swim, we push the water under our stomach or we push the water outwards. Okay, therefore the swimming also is explained by using of the Newton's third law. Okay, bird flying is explained by using the Newton's third law. Okay, and here the rocket accelerates by, we can explain that rocket works on the principle of Newton's third law. That means here the force of the rocket, the gases which are present in the rocket exerts in the downward direction. Due to of the force exerting in the downward direction, the rocket will be pushed upwards. Okay, that means here normally when if you take a toy rocket, okay, if you take a toy rocket normally, and during the Deepavali or Diwali, we use the, okay, we keep a bottle. Okay, in the bottle normally we'll be using of a rocket. Okay, when we burn the rocket, the gases which are present inside the rocket, that means here in the rocket, in the toy rocket, normally the chemicals are present, different types of the chemicals are present. Therefore when they are get lighted, when they are get ignited, they pushes the gases, that means they push the gases in the downward direction. When they push the gas in the downward direction, as the force is exerting in the downward direction, the rocket is pushed upwards. Okay, the rocket is pushed upwards, it will be moving in the upward direction. Okay, therefore here we say that the lighting, the gases coming out is the action. The gases which are releasing from the chemicals after ignited is the action, and rocket moving upwards is the reaction. Okay children, therefore here we say that action is equals to minus reaction. Action is equals to minus reaction. Action is in the downward direction, whereas the reaction is in the upward direction. Okay, normally here